Okay, here's another one that you should actually be able to do. Let's take a look at this equation. So r cosine theta equals -2. So that's my polar equation. I want you to pause the video for a moment and see if you can figure out what r cosine theta represents. You definitely want to put this in your little book. Okay, so now that you've taken a look at it, remember that r cosine theta is equal to x. So x is going to equal -2. So if I find x at -2, that's this point right here, and I go up and down from it, hopefully get a little bit better here. I should be able to get a line that roughly meets at -2. And so here we have a graph of a vertical line. So the line that you get is going to be the opposite of what your axis is. So your x-axis is horizontal, so it's going to give you a vertical line. Your y-axis is vertical, so it's going to give you a horizontal line. Okay, this next one is a little bit tricky. That's why we're going to be going over this together. Identify and graph the polar equation by converting the rectilinear equations. Identify and graph the equation. Use the techniques from the last section to convert the polar equation to a rectilinear equation. Okay, so this is one of those things that's almost, I don't know, almost like a little bit of an exception. When I look at this one, so we have theta equals pi over 3. It doesn't do me any good to square it. It doesn't really do any good for me to multiply it by r. So I have to look at what kinds of things can I come up with that will ultimately give me x and y. And so I think about my trig functions, and what I can do is multiply both sides by tangent, and that's legal. I can do that as long as I do it to both sides, right? Tangent of pi over 3. Now here's where we got to actually figure out what the tangent of pi over 3 is, because we need that as a number. So in this, you can say that well, let's figure out um, our piece here. So if we have pi over 3, my y value of pi over 3, as far as cosine, right? I should say cosine, or sine. Here. The sine is going to be square root of 3 over 2, and my cosine is going to be 1/2. Now, if I take a look at the tangent, that's going to be equal to the sine over cosine. So the tangent of theta will be equal to square root of 3 over 2 over 1/2. And those little 2's on the denominator are going to cancel out. So the tangent of theta is actually going to be equal to the square root of 3. So now we can go back to our original equation, and I can say the tangent, which we know is y over x, is equal to the tangent of square root of 3. Does that make sense? Okay. So even as we did the tangents, I'm going to go ahead and undo that from both sides, and I'm left with y over x is equal to the square root of 3. And then I could actually turn this into an equation. So y is equal to root 3 times x. So this would actually be the slope of my line, and I know that the angle is pi over 3. So that's going to go through pi over 3, but be a straight line that continues to go through there. Okay, so this one's a little bit more involved. So the equation is the graph of a line. Okay, and then this is what our graph is going to look like. I could have just taken that angle and extended it. That would probably be the cleanest thing to do, but I did want to show you the logic behind how I can actually get it into an equation if I needed to.